I've deployed machine learning systems that process over 200 million transactions daily, improved credit risk accuracy by 18%, and built RAG pipelines serving thousands of users daily. But how do I know if these systems are actually making the world any better? Traditional benchmarks tell us that our models are accurate, but they don't tell us if the users are becoming over reliant and if decision making skills are atrophying. Hi, I'm Toshali, and the work presented by Schwartz and al. Reality check paper articulates a similar problem that I have grappled with throughout my career. That is, bridging the gap between technical as well as real world impact. The paper resonates with me because it addresses one of the most critical challenges in production, that is, understanding what happens after deployment. I've learned that the hardest problems in deployment aren't usually technical, but they're socio-technical in nature. How do users actually interact with your system? What behaviors emerge over time? And how do you measure success beyond the so-called accuracy metrics? The authors call for a new evaluation ecosystem that aligns perfectly with my belief that responsible AI requires going beyond the first order effects. When I improved time series forecasting across 33 test markets, the real challenge wasn't achieving 32% accuracy improvement. In fact, it was all about understanding how those predictions influence trading decisions, risk management strategies, and ultimately the market stability. What excites me about this research is its systematic approach to the complex questions involved. The framework that they propose, which basically includes context specification, field testing, and red teaming, provides a structured methodology for the kind of holistic evaluation that I've been seeking throughout my career. This isn't just academic theory, but it's a practical roadmap for building more responsible AI systems. The paper's emphasis on field testing particularly resonates. In my A/B testing frameworks, I have learned that short-term conversion metrics often miss long-term behavioral changes. When I was working on credit risk modeling, we found that improved model accuracy initially increased the approval rates. But over a span of 6 months or so, it subtly shifted underwriters' decision making patterns in ways our original evaluation framework couldn't capture. What's particularly compelling is the focus on systemizing the real world concepts as well. This addresses a persistent challenge that I have faced, which is translating ambiguous business requirements into technical specifications. The frameworks that have been proposed for creating technically neutral as well as collectively informed decisions could revolutionize how we bridge the gap between stakeholder needs as well as model objectives. From my causal inference background, I am fascinated by the paper's focus on second order effects. Having worked with complex systems processing millions of transactions, I have seen how small changes can cascade through entire ecosystems. I'm particularly intrigued by the scalability challenge that has been acknowledged here. How do we balance the depth of ethnographic studies with the modern scale AI development? My experience with enterprise-grade ML systems suggests that we need hybrid approaches, that is, using qualitative insights to inform automated monitoring systems which can operate at a large scale. This paper also kind of raises profound questions about adaptive governance that connect to my work in related industries. How do we create evaluation frameworks that evolve with the understanding of AI's impact? How do we build systems that can detect and respond to emergent risks that we haven't yet imagined? These questions become even more critical as we deploy increasingly capable models in high stake environments. This paper challenges us to think beyond technical metrics towards genuine societal impact, and that's exactly the kind of challenge that I want to pursue at Cohere Labs. My experience in scaling machine learning systems has taught me that our responsibility doesn't end at deployment, it begins there. So I'm excited about the possibility of contributing to research that just doesn't advance AI capabilities, but also ensures those capabilities serve humanity as well. Because the most important question isn't whether our models are accurate, it's whether they're making the world a better place. And answering that question requires exactly the kind of rigorous and interdisciplinary approach that this paper advocates. Thank you.